Unlock the big question. I will know what sound energy is and how it is produced. Words to know. Sound, pitch, frequency, volume, wavelength, amplitude. Sound energy. The blare of an alarm clock, the beep of a car horn, the quack of a duck, and the rumble of thunder during a storm are all sounds. Sound is energy in the form of vibrations passing through matter. A vibration is a quick back and forth movement. Sounds occur when objects vibrate. Sound travels through solids, liquids, and gases. Sound cannot travel through empty space, where there is no matter. Matter is needed for sound because collisions between particles and matter can cause some energy to be transferred into the air. The air gets heated, and sound is produced. Pluck a guitar string, and the string starts to vibrate. The vibrating string collides with the particles in the air around it and passes energy to the air. The sound energy travels outward as sound waves. A sound wave is a disturbance that moves sound energy through matter. When the waves reach your ears, the waves make your eardrum vibrate, and you hear the sound made by the guitar string. 1. Underline words that tell what sound is. 2. Explain. A plucked guitar string will make a sound until the string stops vibrating. How might you play a short note? How sound travels. As sound waves move through matter, they set particles into motion. The moving particles form a pattern. Areas with groups of particles that are bunched together alternate with areas of particles that are farther apart. The areas where particles bunch together are called compressions. Sound waves travel at different speeds through matter. Sound waves travel quickly through most solids and liquids. Sound waves tend to travel more slowly in gases. 3. Identify. Circle the compression images in this picture. 4. Main idea and details. Circle the main idea in the first paragraph above. Underline 3 details. Do the math. Read a graph. This graph shows the speed of sound through some common materials. Use the graph to answer the following questions. Approximate speed of sound. Speed, meters per second. Types of medium. 1. Compare. Does sound travel faster in air or in fresh water? 2. Compute. About how many meters per second faster is the speed of sound in steel than in brick? Frequency and wavelength. Waves can travel in different ways. They can carry different types and amounts of energy. But all waves have certain properties. Frequency and wavelength are 2 of these properties. The frequency of a wave is the number of waves that pass a point in a certain amount of time. Frequency is often described as the number of complete cycles a wave makes in 1 second. A cycle is one vibration. Wavelength is the distance between a point on one wave and a similar point on the next wave. Studying sound. One way scientists study sound is by using oscilloscopes. An oscilloscope is a device that takes sound waves and displays the shape of the waves on a screen. Look at the oscilloscope screen below. The signals are displayed on screen in the form of a wave. Compressions in a sound wave show up on screen as crests, or high points on the wave. The spaces between compressions show up as troughs, or low points on the wave. Notice how the pattern resembles ripples in water. Waves like this one can be made in water by tapping the surface of the water. The ripples are the crests and troughs of the waves. 5. Analyze. Which has a higher frequency? A wave that makes 6 cycles per second, or one that makes 10 cycles per second? Explain your answer. Wavelength can be measured between 2 crests or between 2 troughs. The slower an object vibrates, the longer its wavelength and the lower its frequency will be. If this screen represented 1 second, this wave's frequency would be 2 cycles per second. 6. Label. Where are the compressions in both images to the left?
Mm-mm.
Pitch. People experience the frequency of
No.
sound as its pitch. Pitch is how high or low a sound is. Pitch depends on the frequency of the sound wave. Objects that vibrate more quickly have higher frequencies. Those objects have a higher pitch. Objects that vibrate more slowly have a lower frequency and a lower pitch. The material of the object making the sound and its size and shape affect the pitch you hear. A tuba, for example, is a musical instrument made of many feet of brass tubing. Tubas make low-pitched sounds. Some sounds are too low-pitched or too high-pitched for humans to hear. 7. Apply. Put your hand on your throat and make a low-pitched sound. Then make a high-pitched sound. Explain how your throat adjusts while making these sounds. A dolphin communicates by making high-pitched sounds. 8. Explain. Are dolphin sounds high or low frequencies? Volume. When you describe a sound, probably one of the first things you think about is loudness or volume. You know that some sounds are louder than others. A jet engine, for example, makes much more noise than a car. What exactly is volume? Volume is a measure of how strong a sound seems to us. The more energy there is in the sound wave, the louder the sound and the higher the volume. The volume of a sound is related to its amplitude. Amplitude is the height of a wave measured from its midline. The higher the amplitude of a wave, the more energy it has, and the louder it sounds. Suppose you turn down the volume on the TV as soft as it will go. You can barely hear it. Then, you turn it up as high as it will go. Now you have to hold your ears so they don't hurt. You have not changed the pitch of the sound. You have changed its amplitude and its volume. Lightning Lab. Water music. Fill 4 bottles with different amounts of water. Blow across the top of each to make a sound. Put the bottles in order from low sounds to high. What do you notice about the sound and the amount of water in each bottle? Nine. Recall. Label the parts of this wave. Midline. 10. Predict. This wave represents a changing sound. Explain how this wave is changing. Got it? 11. Explain. You stand outside a room that has the doors and windows closed. Why can you still hear sounds made inside the room?